Hello friends, welcome to VK lectures. In this lecture we will be discussing the question number 7 and 8. Hope you have done the previous two questions that was given as the practice questions. Now let us see those practice questions now. Now here we have the matrix and we are asked to check if the matrix is an element of SU of 2. The SU of 2 is nothing but spatial unitary matrix. Now to check whether it is a element of spatial unitary matrix, there are three criteria. The first one is it should be complex matrix. So to have this as a complex matrix, you need at least one complex number as an element in the matrix. So there is two numbers, so which is a true statement here. This is a complex matrix. Now the second one is to check the determinant. The determinant has to be equal to 1. So determinant must be equal to 1. And the third one is find the complex conjugate transpose, that is U dagger U equal to the identity matrix, and that should be equal to U dagger, or U star U equal to I, that's equal to U star, sorry, U star. Okay, so this is what we need to check. Now first one is a complex matrix because it has got a complex number. Now check the determinant. Now this is our matrix 1 by root 2 minus I by root 2, I by root 2 and 1 by root 2. This is A, B, C and D of a 2 by 2 matrix. Now the determinant is given by A into D minus B into C. This is AD minus BC. So this gives us 1 by root 2 into 1 by root 2 minus I by root 2 into I by root 2. Now I into I is equal to minus 1. So plus 1 minus minus and minus. So this gives us minus. So 1 by 2 minus 1 by 2, this is 0. So determinant of the matrix, let us call this matrix as U, is equal to 0. So the second criteria is false. It is not satisfying the second criteria, so determinant is not equal to 1. Now checking the U dagger U equal to I or not, we have our, okay, it's not U, we have A here. So A dagger A should be equal to I. Now this is our A, and now what is A complement? A complement is complex conjugate of 1 by root 2 is 1 by root 2. Complex conjugate of minus I by root 2 is I by root 2. Complex conjugate of I by root 2 is minus I by root 2, and complex conjugate of 1 by root 2 is 1 by root 2. Now we have to replace all the elements with its complex conjugate. So what we are going to get is here 1 by root 2, and now change in the diagonal element. So here we have 1 by root 2, 1 by root 2, and this is I by root 2, and this is minus I by root 2. Now this is what we have got here, that is 1 by root 2, I by root 2, minus I by root 2 and 1 by root 2, and its transpose is 1 by root 2 minus I by root 2, I by root 2 and 1 by root 2, and this says that the A dagger, that is the complex conjugate transpose, is nothing but the A. This is the same as the matrix that we have A. So when you take the complex conjugate and take the transpose, this becomes this one, and this is it. Okay, now we need to find out a dagger a, and since a and a dagger are same, what we can find is 1 by root 2 minus I by root 2, 1 by root I by root 2, and 1 by root 2. Now the same things we have to write it here. So this is a and this is a dagger and this is a, and its product gives us this is 1 by 2 times 1 by root 2 times 1 by root 2, that is 1 by 2, plus minus I by root 2 plus I by root 2, that is minus 1, that is gives again 1 by 2. Now 1 times minus I by 2, that is minus I by 2, plus minus I by root 2 times 1 by root 2, that is minus I by 2, and I by 2 and I by 2 plus I by 2, and again we have here I times I 1 minus 1, that is 1, so 1 by 2, and 1 times half, that's 1 by 2. So this is the product a dagger a, that's equal to 1 minus I and 1. So this is what it is, and this is not equal to the identity matrix I. Okay, now in the earlier case we have found out that determinant is equal to 0. From here itself we can say that our matrix is not a element of SU of 2, is not an element of SU of 2, so it's not an element. Okay, that means the matrix A is not an element of SU of 2 because determinant is equal to 0. Now if determinant exists, it's equal to a non-zero value, which means inverse exists, inverse will be existing. Okay, so there must be an inverse for A that will be equal to A inverse. Now if we are writing the unitary matrix and we say that a dagger A equal to I, it is simply means that A into A inverse equal to I. That means A times A inverse is equal to I, matrix into its inverse equal to I. Similarly, the third item that we have here, that is A dagger A should be equal to I, which means A times A dagger should be equal to I. This, from these two we can tell that A into A inverse equal to I, A into A dagger equal to I, and A inverse equal to A dagger, right? And the inverse is itself this one, because we already know that A dagger equal to A, that's equal to A, but this does not exist because there is determinant equal to 0. Since determinant equal to 0, there is no inverse, does not exist. So we can say that A dagger A is not equal to I because it is not the inverse. Okay, so that's regarding this question. Here we have the question DS2. So this is the question DS2, the separation in the x1 x2 space. So this is x1 x2 space. Here we have dx1 squared plus 2 dx1 dx2 plus 3dx2 squared. Now we need to have the we are just rearranging this one, dx1 squared plus dx1 dx2 plus dx2 dx1 plus 3dx2 squared. Now we need to have the matrix. This is called coefficient matrix, dx1 dx2 dx1 and dx2, and we need to write down the matrix. This is dx1 squared as 1, dx1 1 1, and the coefficient of dx2 squared is 3. So this is the matrix, and now we need to find the determinant of the coefficient matrix C. So this let us write it as the matrix C. So determinant is 3 minus 1, that is 2, and now we need to find out the cofactor matrix. The matrix that's equal to minus 1 to the power I plus j, and since it is 2 by 2 matrix, you have to remove ith row and jth column. What you are getting by removing ith row and jth column, that's your answer. So first one is 1 comma 1, that is 1, and 3 will remain. So the cofactor matrix we will write it as C dash. So let that be equal to 3. This one will change into minus 1, this again, this becomes minus 1, and here it becomes 1. So this is the cofactor matrix, and we have to divide to find the inverse. We have to divide by the determinant, so 1 by C into cofactor matrix. So this gives us 3 by 2 minus 1 by 2 minus 1 by 2 and 1 by 2. So what are Gij's? Gij's are G11 equal to 3 by 2, G12 is equal to minus 1 by 2, G21 is equal to minus 1 by 2, and G22 equal to 1 by 2. So this is the answer to this question, that are the contravariant elements of the given x1 x2 space. What is the probability of getting 3 heads and 2 tails when 5 fair coins are tossed together? Now this question can be done using the binomial distribution. So the binomial distribution says the probability of getting 3 in favor out of the 5 trials. We are assuming that 3 heads are that we need. When we need 3 heads, 2 tails, 2 will be tails, because the coins are fair coins, or it will be also written as unbiased coins. Now, so probability of getting 3 in favor out of 5 trials is given by NCR, that is the combination, out of n trials C. Okay, so we'll CR P power R, that means the favorable probability times R, Q power n minus R. So this is P n of R, that's given by NCR P power R, Q power n minus R. Now P P is the favorable probability. Now what is the probability of the what we require? Heads, that is 1 by 2. Out of one coin it can be either head or tail. Now Q is unfavorable probability, and that's equal to again half. Now substituting this, P5 of 3 is equal to n, 5 times the combination of 3, P power 3, Q power n minus 3 is 2. So that's equal to 5 factorial by 3 factorial into n minus r, 5c. So NCR equal to n factorial by r factorial into n minus r factorial. So 5 factorial into 3 by 3 factorial into factorial into 1 by 2 whole to the power 3 times 1 by 2 whole to the power 2. So this gives us 5 factorial by 3 factorial, that is 3 factorial into 4 into 5. This I can write it as 5 factorial as 3 factorial into 4 into 5 divided by 3 factorial into 2 factorial times 1 by 2 to the power 5. That's nothing but 10 into, that is 4 into 5 by 2. 3 factorial and 3 factorial get cancelled. So 10 times 1 by 2 to the power 5. So 1 by 2 to the power 5 is 1 by 32. So 10 by 32 is nothing but 5 by 16. So it's 5 by 16. So option C is the answer. If a variable x has a probability distribution of p of x is equal to 1 by sigma times root of 2 pi into exponential minus x square plus mu x by 2 sigma squared, then its mean value or the average is given by. Now before going to the question, let us understand how we can write the f of x, the function, that is the probability distribution function on Gaussian function. So this is a Gaussian distribution function. Okay. Now this is equal to 1 by sigma times root of 2 pi into e to the power minus x minus mu whole square by 2 sigma square. Now here mu is the mean and sigma is the standard deviation. Okay. And so we can write the coefficient of x is nothing but the mean value. Now here this x square plus mu x, we can write it as x plus mu by 2 whole squared. We will have will be with left with some constant, but we will not worry about it. So this gives us x square plus mu x, and this one gives us x square plus mu x plus mu square by 4. So we need the coefficient of x, right? So here we have written x plus mu by 2. This we can write it as x minus of mu by 2. Alright, so x minus of mu by 2 whole square, which means this term is what we need, because x minus mu, so this is mu or the mean is equal to minus mu by 2. So the answer is option B. So once again, here the distribution function Mu is the mean and sigma is the standard deviation. Here we have an interesting question for practice. We are asked to find the probability of getting two heads when tossing four fair coins. I mean, at least two heads when tossing four fair coins. Four options are given. You can comment your answer in the form of options. Thank you.